Hello everyone, we're from the Department of Electrical Computer Engineering, and we designed an e-bike conversion kit. So, for our team, we have Derrin Couture, Jonathan Tu, myself Marlin Johnston, and Jaden Redding. So for the presentation, we're going to talk about the design problem, we're going to define it, and show you what we came up with. So for some background motivation here. Bicycles are efficient, small, and quiet. However, they're only good for healthy people who are willing to exercise. E-bikes solve this problem by increasing the capabilities of a bicycle and their rider. Also, compared to cars, e-bikes produce less emissions, less liabilities, reduced traffic, and lower maintenance costs. As you can see from this diagram here, e-bikes are much more efficient on their energy usage for commuting. So for the problem definition, e-bikes are becoming a popular mode of transportation that offer a longer and more enjoyable ride. So, an inexpensive conversion kit is needed to transform a regular bike into an e-bike. So we have some constraints and objectives for our design. Max weight of 30 pounds, total cost must not exceed $1,000, and a max speed that must not exceed 30 kilometers an hour on flat ground. So objectives we're aiming for is quick to install and detach, intuitive controls, speed of up to 30 kilometers an hour, and a battery life of an hour. For major requirements, we have a couple here. The main ones are a rechargeable battery, a motor power between 270 and 500 watts, controls that are safely operational with one hand while riding a bike, and speed adjustable via pedal assist and throttle.
Our design is separated into four main components. First, there is our motor, which spins our wheel. Then you have the motor controller. This is the central hub of the system, and its purpose is to drive and regulate the speed of the motor. On top of that, you have the peripherals. These are the user inputs for actually operating the bike. Finally, there is the battery, which provides power for all of the systems. For our motor, we used a 500-watt front hub motor, and this sits in the front wheel of the bike for easy access. For our power supply, we actually built our own battery. This is a 36-volt battery, which can supply 10.5 amp hours and has a recharge time of about 5 hours. For a motor controller, we used a VESC 4.12. This is an open source controller commonly used in electric skateboards. Finally, we have the peripherals. Here, we coded an Arduino microcontroller to take in all of our user inputs, like the throttle, brake sensor, buttons, and pedal sensor, and then communicate with the motor controller to tell it how fast we actually want the bike to be going. Now, with all these components, we eventually then mounted them to our bike, and we were able to start testing. For our testing, we were able to measure a top speed of 25 kilometers per hour using no human power. This is a bit lower than our 30 kilometer per hour goal, but it's still pretty respectable for an e-bike. We also conducted an endurance test and found that the e-bike had a battery life of 1 hour at full throttle, which met our battery life goal and we were quite satisfied with. In the same endurance test, we also found the bike had a range of 25 kilometers on a fully charged battery. To put this in perspective, the radius of Saskatoon is only 10 kilometers, so on one full charge, you should be able to get just about anywhere in Saskatoon, assuming flat ground. Finally, to finish the presentation, here's a quick demo of the bike in action. With all being said, thanks for watching.